Welcome to the Diary of an Embedded Systems Lover. Let's understand the working principle of 7-segment display. These 7-segment displays are commonly used in wristwatches, in speedometers, and even in digital clocks. Almost in every application where numbers are to be displayed, these 7-segment displays are used. So basically, these 7-segment displays are nothing but 8 LEDs arranged in this fashion. We have A, we have B, we have C, we have D, we have E, F, and G. Alright, so we have the A, B, C, D, E, F, and G arranged like this. So these can display numbers between 0 to 9. Alright, the 7-segment display can display between 0 to 9. And here are the terminals: terminal A, terminals B, terminal D, C. The next terminal is terminal D, terminal E, F, G, and then you get to H, and then you have the common, and this is the common, which can either be common cathode or common anode. All right, so these are the terminals for the 7-segment display. Like I said, the 7-segment displays are LEDs, and the terminals are based on LEDs. All right, so these 7-segment displays are classified into 2 types, which is a common cathode and common anode. Why? Because an LED has either anode or cathode. So the 7-segment display is either in common cathode or common anode.
The 7-segment display will look like the picture above, and the center pins are a common pin to the ground. All right, so you can see the center pin is a common pin to the grounds, and we must provide a common supply based on the type of display we're working with. First, we look at the common cathode display. You can see all the cathode of the LEDs are connected together to the ground, making it the common cathode. So let's assume that we use internal LEDs such as A, B, C, D, E, F, G, H to represent the 7-segment display. So we use LEDs, internal LEDs, to represent the 7-segment display. So these LEDs are arranged accordingly to these alphabets. Now you see that all the cathodes of the LEDs are commonly sorted and provided with a ground. So this is the common terminal. So in the case of common cathode, we provide ground to the common pin, which is linking all the ground pins of each LEDs. So each of the cathode pins of the LEDs are all connected to the common, which is the ground. That is why it's called the common cathode. All right, so now let's test and see how the common cathode works. All right, so I just played the simulation, and now what happens is that when I supply 1 in the logic state to A, the respective LED comes on. So whenever I supply a positive supply to the anode of the LED comes on. All right, so this is how the common cathode display works. Whenever we supply a 1, which is a positive supply, to the display, that respective LED turns on. So this is the working principle of the common cathode for the 7-segment display. So it works in such that whenever we supply a positive voltage. That's by turning on the logic state by making it 1. The respective LED turns on. This is the common anode of the 7-segment display. You can see the LEDs connected to represent the 7-segment display. This is just a direct opposite of the common cathode. So this is a common anode. What that means is the common is connected to positive anode. So to turn on the respective LEDs, we need a 0, and to turn it off, we need a 1 in the logic state. So that is why the logic 1 has turned off each of the LEDs, which is an opposite of the common cathode 7-segment display. So this is how the common anode works. The common anode needs a negative power supply to turn on the respective LED in the 7-segment display.
Here is the 8-bit 7-segment display connection with the 8-bit pin of the microcontroller. So pin A of the 7-segment display is connected to the 0-bit of the microcontroller, and pin B is connected to the 1-bit. Pin C is connected to the 2nd bit. Pin D is connected to the 3rd bit, and then to H, and here is the ground. So this is the ground pin, which is connected to the common of the 7-segment display. So now let's simulate and try to display from 0 to 1. All right, so to display 0 is OX3F in terms of the hexadecimal, and 0 display. And let's display 1. To display 1, it is 0x06. And let's display 2. To display 2, we would use 0x5b to display 2. 0x5b to display 2. And let's display 3 in the 7-segment display. To display 3, it is 0x4f to display 3. 0x4f, sorry. Now let's display 4. To display 4, it is 0x66. And let's correct this. We're about to display 4. 4 to display 4 is 0x66. Now let's display 5. To display 5, it is 0x6d. To display 5, it is 0x6d. Let's display 6. To display 6 is 0x7c. 0x7c. And let's display 7. 7 is the next, and to display 7, it is 0x07. To display 7, 0x07. And to display 8, 8 is the next to be displayed. To display 8, it's 0x7f. 8 is 0x7f is the hexadecimal. 9 is 0x6f. To display 9 is 0x6 6F. So this is the hexadecimal of all the bits representation of the 7-segment display and how to display it. So, and we get to turn off the 7-segment display with a 0. This is the common anode type of the 7-segment display, which is an opposite of the common cathode, because the common here is connected to the positive power supply. And now let's turn on 0 in the common anode 7-segment display. 0 in hexadecimal is 0xC0. Then to turn on 1, the hexadecimal for 1 is 0xF9. 0xF9. Now let's turn on 2 in our common anode 7-segment display. To turn on 2 is 0xA4. 0xA4. And to turn on 3 in a hexadecimal is 0xB0. 0xB0. Then to turn on 4 is 0x99. 0x99. Four is 0x99. Let's turn on 5. To turn on 5 in hexadecimal, it is 0x92. 0x92. Then to turn on 6 is 0x82. 0x82. Let's turn on 7. 7 is 0xF8. 0xF8. Then to turn on 8 is 0x80. 0x80. Then to turn on 9 is 0x90. So this is a common anode type of the 7-segment display. And please like and subscribe and share this video, and drop your question if you have any question about this video in the comment section below. Drop your question. Alright, so to understand how to program the 7-segment display, you must understand how to configure the common cathode and common anode. Here is a circuit simulation of the 7-segment display using the Wokwi Arduino simulation environment. For the circuit diagram and the code, click on the link in the video description below. You get it. So the code is done uploading on Arduino microcontroller. This is the Arduino IDE, and this is the final code upload. And this is the live demo of the 7-segment display, and it's working perfectly well as programmed. So if you like this video, give me a thumbs up, just like the video, and subscribe to my channel if you are new to this channel, and drop any question you have about this video and I'll do it to reply. Thank you for watching. See you in my next video.